Welcome to LDI 1.7. In this LDI, what we're going to do is talk a little bit more about the direction of extreme and expanding a rejection region and see if we could do a little bit of calculation of alpha and beta. So in the current example that we've been working on, the bag A, bag B example, we had a one-sided rejection region to the right. But we know from our previous work, go back to example 1.1, that that's not the only possibility. You can have a rejection region to the left, or you can have a rejection region to the right, or you can have a rejection region to both the right and the left. In other words, a two-sided one. Okay? So how do you make the determination of which way your rejection region is? Well, your rejection region is always determined by your direction of extreme. All right? This actually turns out to be kind of a sort of common sense thing here. If our null hypothesis is that you have bag C, in other words, if this is the null here, and the alternate is that the bag is bag D, well, notice that if I pull a $1 voucher out of the bag, that wasn't very likely to be in bag C, but on the other hand, it was very likely to be in bag D, and that would cause me to reject the null and accept the alternate, right? On the other hand, if I pulled a $5 voucher, I would be very likely to say that it's bag C, and I would assume that I would be rather wrong if I said it was bag D. Now, I could have made a mistake in both cases there, right? Those mistakes, where we're about to calculate, have to do with alpha and beta. So in the original example that was in the textbook, they chose the critical value to be $1 or less. Now notice the or less points in the direction of extreme, okay? And when we did that, we ended up with an alpha, using decision rule 1, of 1/15th, okay? And a beta, see the alpha would have been calculated in my table here. That would have been alpha, okay? And then the beta, using that decision rule, would have been calculated this way, and that would have been what? 10/15ths, okay? If you do the calculation, okay? Go back and take a look at the example in the book if you need a little bit of refresher there. Now what we want to do is we want to change that, all right? So if we want to go change that, what we're going to do now is we're going to expand our rejection region, okay? We want to make beta a little bit smaller because the beta came out to be pretty big, came out to be basically, what, 67%, okay? So what's the next most extreme value among the values of $2, $3, $4, and $5? Well, hopefully it's pretty obvious to you that it's $2. But let's go back and take a quick peek at the graph and see what's going on there. Notice that the current critical value with decision rule 1 is $1. Well, if we move over to 2, notice that would set up our new decision rule, and our new critical value would be $2. Okay, so let's go answer that question real quick. Pretty easy here. We're just going to go, hey, yeah, I know what it is. It's $2. Okay, so decision rule 2, now based upon that, is going to become what? Well, decision rule 2 says reject the null. Oh, sorry, I already said that. I said reject, sorry about that. So reject the selected voucher is $2 or less. I'm trying to make it as easy as possible on me. I was trying to make it harder. Okay, so if it's $2 or less, we'll reject the null hypothesis. So now what's my new rejection region? Well, my new rejection region, I guess probably the easiest way to help them out here and tell them what we want to tell them is a rejection region contains the values of what? $1 or $2. So if I pull a $1 voucher or a $2 voucher, I will reject the null hypothesis. Notice all of this is all happening up here in the distribution of the null, okay? All right, so based upon this new decision rule, we're going to want to calculate what the new value of alpha is going to be. Okay, now remember, we're one-sided to the left. And since we're one-sided to the left, the level of significance alpha, which is the probability I'm making a type 1 error, is going to be calculated by taking all of the values from the critical value to the left. In other words, 1, 2, 3 values out of 15, or 3 vouchers out of the 15. So alpha is going to be equal to 3/15ths, okay? So how are we going to calculate beta? Well, if alpha went that way, then beta is going to go this way. In other words, if alpha is to the left in the distribution of the null, then beta is going to be calculated to the right in the distribution of the alternate. So let's check out and see what happened to beta here. Beta is going to be what? 1, 2, 3, 4, 5, 6. Beta is going to be equal to 6/15 now. Okay? Alrighty then. So let's go back and fill that information back here. Alright? So they want us to know, based on our new decision rule, what is alpha and what is beta. Okay? So alpha turned out to be, go back and take a quick peek here again, what was it? Oh, it's 3/15, right? Now if you want to write that as 3/15, that's totally good. Let me get what I wanted here. I can go with that's 3/15, but of course we know that you can simplify that. 3/15 is the same thing as what? 1/5, right? Or if you choose to, you can go get out your calculator, and if you don't remember off the top of your head, let's go ahead and clear all this stuff out of here, and we can go see, well, what is 1/5 or 3/15 as a decimal? And that turns out to be 0.2, right? Okay, so we could say that that's also, if you want to, you could say it's also or equal to 0.2, which is equal to, if you want to call it a percentage, 20%. Okay. All right. Let's get that lined up a little better there. Not quite lined up with my other ones. Come back here, you. There we go. All right. So, what about beta? Well, beta. Okay. If you recall back here, beta was 6/15. Okay, so we can write down beta. We've got some alternate answers we can put in here also. So beta is what? 6/15, which we know is the same as what? Well, let's see. That would be the same as 2/5, right? Is that right? 2/5 and 6/15 are the same? Because you take 3, yep, 2/5, okay. Which is equal to, again, now if you want to go check this out on our calculator, we can go get that real quick. And we can get over here, come here, where's my pen, and we can go, okay, 6 divided by 15 as a fraction, and we come out with 0.4, which hopefully you could have done that without the calculator, but hey, let's just show off the calculator anyway, right? So that's going to be equal to, just a sec here and get this thing right where I want it. Oh, come on, you know, sometimes this thing just has to argue with me, right? So that's equal to 0.4, or if you wanted to write that as a percentage, that would be 40%, okay? So how do these values compare to decision rule 1? Well, the main thing you need to write here, it's not hopefully rocket science at this point, we've been seeing this quite a bit, is that what happened was, as alpha increased, beta decreased. Okay, and that really is the punchline of this LDI, is to notice that the relationship between alpha and beta is, as we've seen, you can almost kind of intuitively just get it by looking at the graphs or looking at those charts, that as you make alpha bigger, you make beta smaller. As you make beta smaller, you make alpha bigger. Or if you make alpha smaller, you make beta bigger. Okay, so they're inversely related to each other is the basic idea. Okay, well, hopefully you got the gist of what we were doing there, and please don't be shy about sending Michelle and I questions, okay?